Good morning everyone. So welcome to my YouTube channel Vyas. So today we are going to start a topic which is the power series and we will discuss first lecture on it. Okay. So what is the definition of power series? A power series about x is equal to a is a series of the form so power series about x is equal to a is a series of the form summation summation n is equal to n is equal to 0 to infinity Cn x minus a to the power n. Okay. So if we will expand this, what we'll get? C naught x minus a to the power 0 means what? It will be 1. So we will write it C naught because x raised to the power x minus a is nothing but 1. Okay. Then C1 x minus a plus C2 x minus a square. And this will go like that. And last term and the general term is Cn x minus a to the power n and so on. It will go like that. Okay. So this is the power series. It is of this form where in which a is called center of this series and C naught, C1, C2, Cn and so on. Also a. These are actually constants. These are constants. So so A is also constant, but I'm not writing like that. A will be also constant, but A is called center. Okay. These are the constants, C1, C. They are the coefficient of the series. Okay. A is called center of the series and C0, C1 are constants. Okay. So example 1. So if we take A is equal to, if we take A is equal to 0 and C0, C1, we are taking this one. then the power series is summation n goes to 0 to into to x to the power n. What is this? This is 1 plus x square. The center is 0 here and the coefficients are okay. Coefficients are C0, C1, Cn. Okay. So we know this series converges. We already know this series converges or it means x will be in this range. Okay. We already know from our 12th standard knowledge. Example 2. Okay. So here these are constants. They are called constant coefficients. In power series, A is also constant, that is called center of the series, and Cn, they are constant coefficients of this series. They are coefficients of the series. Or you can say coefficients only, okay? Now consider this power series. The power series 1 minus 1 upon 2 x minus 2 plus 1 upon 4 x minus 2 square, then minus 1 to the power n x minus 2 to the power n. So what is center here? Center of the series is 2. Okay. And what is coefficient? Coefficient Cn is minus 1 to the power n. Okay. Now we know this series converges. So this is geometric series. This is geometric series. Geometric series with common ratio r is equal to minus 1 by 2 x minus. Okay. Therefore, we know geometric series converges if common ratio value is 1 less than 1. Okay. Common ratio value is. So what does it mean? It means this implies Okay. So this series converges if this series converges if you can use in earlier example also one summation 1 x to the power n, that is also geometric series. Okay, no problem. Now we will do some example. Example number 3. For what values of x do the following power series converge? Solution. What are the power series? Let's see. Summation n goes to 1 to infinity minus 1 to the power n minus 1 x to the power n upon n. What is this? X minus x square upon 2 plus x cube upon 3 minus x to the power 4 upon 4. Second example is summation n goes to 1 to infinity minus 1 to the power n minus 1 x to the power 2n minus 1 upon 2n minus 1 x minus x upon 3 plus x to the power 5 upon 5. Okay, so this is this. Third example is so I should write here. I'm writing it A, B, C like that. This is A, this is B, this is C, summation x to the power n upon factorial n. So this is 1 plus x square upon factorial 2 plus x cube upon factorial 3. D is summation n goes to 0 to infinity factorial n into x to the power n, that is 1 plus x plus factorial 2 x square x cube. Okay. So see how we will solve it. Solve these questions. Solution. Apply the ratio test. Here. Test. So first example is, what is this? First example is this. Summation n goes to 1 to minus 1 to the power n minus 1 x to the power n upon s. That is x minus x square upon 2 x cube upon 3 minus x power 4. What is un here? What is un here? This implies un plus 1 is okay. So what is un plus 1? What is this? After solving it, you will get this is nothing but minus 1 will be here, and this will be x upon n plus 1 and n will be here. So this implies un plus 1 upon un is equal to, what is this? This is the n upon n plus 1. Okay, so by ratio test, series converges absolutely. By ratio test, series converges absolutely if if limit of n tending to infinity un plus 1 upon un is equal to less than 1. Okay, so this implies what is the limit of n plus 1. So this is actually, this limit is mod x, that is less than. Okay, it means this implies series converges absolutely, hence converges, because absolutely convergent series is convergent if it means x will be indivisible. Okay, again by ratio test, series diverges if limit and tending to infinity un plus 1 upon un value is greater than 1. But we have solved this is this. Okay, so this implies series diverges if it means x is less than 1 and x is greater than. Okay, now by ratio test, ratio test is the ratio test is inconclusive if limit and tending to infinity un plus 1 on un is 1. So we have to check it separately. So what is this? What is this limit? It means the test fails if this. So we will check this value. What is this? X is equal to plus minus 1. So for x is equal to 1, what is the power series? For x is equal to 1, what is the power series? For x is equal to 1, the power series becomes this is the power series 1 minus 1 by 2 plus 1 by 3 minus 1. But this series converges by Leibniz test. This converges. We already checked that this series converges by Leibniz test. Okay. And what about x is equal to minus 1 or x is equal to minus 1? We get for x is equal to minus 1. What is the series? This is the series. So what is this? For x is equal to minus 1. So for x is equal to minus 1, this is minus 1 by 2. Okay. And this is minus 1 by 3 minus 1 by 4. Okay, like that. But this is nothing but 1 plus 1 by 2 plus 1 by 3. Okay. But this series diverges. This diverges. This diverges. So what does it mean? Whole series diverges. The series diverges. So series converges if and only hence power series converges if x in this end. Okay. So this is done. Now second question we are doing converges if x is in this range and diverges elsewhere. And diverges elsewhere. So B, example B are saying, example A is done. Okay, now we are going to do example B. Okay, so what is un? Un is minus 1 to the power n minus 1, x to the power 2n minus 1, 2n minus 1. What is un plus 1? That is minus 1 to the power n, x to the power 2n plus 1 upon 2n plus 1. So what is un plus 1 upon un? So what is inside thing? This is minus 1 and this is x square and this is 2n minus 1 upon 2n plus 1. So this is 2n minus 1 upon 2n plus 1 mod x square. Okay. So what is the limit? Limit and tending to infinity un plus 1 upon un. What is this? This is nothing but mod square. By ratio test series converges absolutely if x square value is less than 1. It means mod x value is less than 1. And diverges if mod x square value is greater. It means the x is greater than 1. So by the series converges in this range and diverges if it means x is less than minus 1 and x is greater than. Now we have to check separately for x is equal to 1 and x is equal to minus 1. Okay. For x is equal to 1, what we have? The series what is this? This is 1 minus 1 upon 3 plus 1 upon 5, 1 upon 7. Okay. By Leibniz test, this series converges. Okay. So in example number 1, actually we made a mistake. In example number, A part, this series diverges. So in last we have written this, that the series, we should write like that. The series, when we are taking minus 1, the series this is series diverging. So I made mistake here. The series converges in this range and diverges elsewhere. Okay. So now the B part, x is equal to 1, the series converges by Leibniz test. Again, now for x is equal to 1, what we have? This series is okay. So this is what is this series? So when we will put minus 1, it will be minus here. So x minus x cube minus 1 will be here. And this will be 1 upon 3 and 1 upon 5 plus 1 upon 7, like that. Again by Leibniz test, this series converges. Or you can say that this is negative times of the series we obtained from x is equal to 1. This is negative term. We can take minus comma. And we have shown for x is equal to 1, the bracket thing is converges. Or you can check separately, this series converges by Leibniz test. Okay. Hence, the power series converges for and diverges elsewhere. So we can write like that. It means the power series converges for if x is less than equal to and diverges for. Okay. Now example number C and third part C we are going to solve. C summation n goes to 0 to infinity x to the power n upon factorial n. So 1 plus x square upon factorial 2 x cube upon factorial 3 and it is going ahead. So un is equal to this, and what is un plus 1? This is x to the power n plus 1, factorial n plus 1. So what is un plus 1 upon un ratio? That is x upon factorial upon x plus 1. So this implies un plus 1 upon un is nothing but absolute x upon n plus 1. So what is the limit of this? So this implies limit n tending to infinity un plus 1 upon un is equal to, for any x, you take any x. What is this limit? N tending to infinity. So x will be come out limit. So this is x, this is 0, this is 0. Okay. So this implies limit n tending to infinity un plus 1 upon un is 0. That is always less than 1. So this implies power series converges for all x belongs to R. It means what? Okay. Converges absolutely for all x belongs to R. Converges absolutely for all x belongs to R. It means for all x belongs to R. This implies power series converges for all x. Okay. Last part we are going to solve D part. This series is given 1 plus x plus factorial 2x square. This is the same. What is un? Un plus 1 is, so what is un plus 1 upon un? So this is n x. So this implies un plus 1 upon un is equal to n more x. Okay. So what is the limit? So this implies limit n tending to infinity un plus 1 upon un. So this is, so what this limit? This limit is if this limit is infinity if x is not equal to 0 and 0 if x is 0. Because if you put x0, this will become 0 and x is not 0, it will go to infinity. Okay. Okay. So, so therefore, for x is equal to not equal to 0, we have limit that is infinity, that is greater than 1. This implies series diverges. Okay. For x is equal to 1, for x is equal to 0, we have a limit n tending to infinity un plus 1 upon un, that is 0, that is like this implies the series converges absolutely for x is equal to 0. This implies the series converges for x is equal to 0. Hence, the power series converges the power series converges the power series converges for x is equal to 0 and diverges else 0. So we can write it means what? The power series diverges for all values of x except x is equal to 0. So this series is convergent only one single point, that is x is equal to 0. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.